Hey Chloe, it's Mrs. Vara. I just thought I would make a quick video to go over the problems you got wrong on that. This is the 10-2 quiz. Both of them, they were all kind of this. There was really only two types of problems that you got wrong. And so it was pretty quick for me to look at it. So if you need to, pause this video and you can take notes on this. But the first question was similar. I shortened this here, but you were finding the cosine of an angle and it told you the terminal ray passes through the point 5, -12. So all I did here, actually, let me reproduce what I did here. So what I did was I plotted the point over 5 down -12. Doesn't have to be perfect. You can estimate it. And then what you want to do is, so this is the ray. So you started here and you went around to here. So this is your full angle. But we want to find the cosine of the reference angle. So the reference angle has the same terminal side as your big angle here. But the reference angle always has to touch the x-axis. So you just drop down or up or whatever you need to until you are at the x-axis. And that makes your 90-degree. And then your reference angle is always tucked right up here in the corner, close to the origin. So when you're doing a reference triangle, one side of your triangle has to touch the x-axis, and then your reference angle will always be tucked right here in the center. Now, if you think about the sides of this triangle, I know this side is, I'm going to write it as -5, but really you can think the side of that triangle is 5, and this side of the triangle, the length is 12. So if I want to find this, which is the hypotenuse, I'm going to say, I can use Pythagorean, and I can say hypotenuse squared equals the legs squared added together. So when I do that, I'm going to get h squared equals 25 plus 144, which is 169. And then I'm going to square root both sides. So I get h equals, I think it was 13, yeah. Square root of 169 is 13. Now technically I should have a plus or minus in here, because whenever I square root both sides, I should have a positive and a negative answer. But I know I'm only interested in the positive answer because it's a length. So this side of the triangle is 13. So now you can picture, this is your triangle that you're working with. Right angle, theta, 5, 12, 13. You should probably write those as negatives too, so you remember. So they asked me to find the cosine of that theta. So the cosine of theta, cosine is always adjacent over hypotenuse. My adjacent edge is the edge that touches my angle, so that's the -5. And my hypotenuse is 13. So the cosine is -5 over 13. They asked you to find the sine of that same angle. Sine is always opposite over hypotenuse. So if this is my angle, the side opposite it is -12. And my hypotenuse is 13. So that was the first couple that you got wrong. The next ones were, and I'll probably redraw this also, they gave you, or they asked you to find a reference angle for this angle in radian measure. So the first thing you want to do is find this angle. Now you could, if you prefer, you could convert it to degrees. But any radian measure with a 4 on the bottom, I'm going to pop in a unit circle here quick. You'll notice these radian measures with a 4 in the denominator are all a form of a 45-degree angle. So this is pi over 4. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. 5 pi over 4, 6 pi over 4, 7 pi over 4. So think about taking the unit circle and dividing it into these pi over 4s. So this would be 1 pi over 4. If I'm going to draw these and then I'll show you the way you can count it. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. And write 4 pi over 4 would just simplify to pi. And pi is the same as 180 degrees. 5 pi over 4, 6 pi over 4. So here's 7 pi over 4. So this angle starts at 0 here, and it goes all the way around like that. So that's the angle 7 pi over 4. They want to know the reference angle. The reference angle is that angle right there. In the reference angle, remember I just said it in the last problem, has to touch the x-axis. So it's kind of the leftovers. You went almost all the way around. The reference angle would be, what's this distance if you keep going? Now you might be able to look at this and think, oh, well, what would be the distance? It would be pi over 4, which is fine. But you can also think, if I go all the way around, that's 2 pi. And I want to subtract the distance I already went. So I want to minus the 7 pi over 4 from the whole, and then that will leave me this section. So if I'm subtracting these, I need a common denominator. So I want to multiply top and bottom of this by 4. So I would have 8 pi over 4. So if I multiply the numerator by 4 and multiply the denominator by 4, I get 8 pi over 4 minus 7 pi over 4. Subtract your numerators. 8 pi minus 7 pi is just 1 pi over 4. So the reference angle is pi over 4. So your reference angle has to touch the x-axis. And then in the next one, they asked you to find the reference angle for 3 pi over 4. So I did the counting thing again, 1 pi over 4, 2 pi over 4, 3 pi over 4. So this is 3 pi over 4. So this right here would be the reference angle. So notice this touches the x-axis. And the reference angle is always going to be less than 90. So it's an angle less than 90, and it touches the x-axis. Like this one up here, this was our reference angle. Notice it's less than 90. So for this one, I know if I go halfway around, that's pi. So I want to do pi minus 3 pi over 4. So pi minus 3 pi over 4. Here's my common denominator. And then I end up with pi over 4 again. So hopefully that helps. If it does not, let me know and we can do Google Meet and do a couple more examples.